Imagine you pick a single direction in the night sky and travel in a perfectly straight line, forever. Our experience on Earth suggests a few likely outcomes. You might expect a physical wall, a shoreline to a cosmic ocean, or to loop back around. These expectations rely on the rules of our daily lives, where every room has a ceiling and every map has a border. But as we look further into the dark, those rules don't fit the data. When a massive telescope stares into a seemingly empty, pitch-black patch of the night sky for hundreds of hours, it reveals something hidden. Tiny specks of light emerge, thousands, then millions of galaxies appearing out of the void. If you identify the absolute farthest point of light and travel toward it, you are heading for what we call the edge of the observable universe. You might expect that reaching that outermost galaxy would bring you to a barrier, but there is no physical wall waiting there. The edge we see for Earth is not an edge of space itself, but a limit of something else entirely. Because light has a speed limit, it takes time to travel across the cosmos. This means that looking across great distances is the same as looking back through history. The further out we look, the further back in time we see. Since the universe is approximately 13.8 billion years old, there is a hard limit on how far light could have traveled to reach our telescopes since the beginning of time. This creates a paradox. If the universe is 13.8 billion years old, you would expect our field of view to be 13.8 billion light-years deep. However, while this photon was traveling toward us, the space it was traveling through was stretching. Today, that farthest galaxy is actually 46.5 billion light-years away. This expansion isn't galaxies flying through a room, it's the fabric of the room itself growing larger. The space between objects is actively stretching, pushing the horizon further out than light alone could travel. The edge of our observable universe is a boundary defined by the speed of light and the expansion of space, rather than a physical end to the universe. We have to distinguish between our observable universe, this sphere of visibility centered on Earth, and the actual universe that exists beyond it. Beyond our sphere, the universe likely continues. It could be an infinite expanse of more galaxies, or perhaps it curves back on itself in a way we can't yet measure. These ideas remain hypotheses, as they lie outside our current reach. If you were to stand on the very edge of our observable sphere, you wouldn't see a void. You would simply see yourself at the center of your own 46.5 billion light-year bubble of galaxies. Our cosmic boundary is a perspective-based limit. From what we can tell, space has no true center and no physical edge to find. But this boundary is changing. Observations show that the expansion of the universe is not just happening, it is accelerating. This acceleration creates a cosmic event horizon. This is the distance where the expansion of space moves objects away from us faster than the speed of light. As galaxies cross this threshold, their light can no longer reach us. The space between us is growing too fast for the photons to ever bridge the gap. We are effectively losing contact with the rest of the universe. These galaxies don't disappear from existence, but they do disappear from our reality. They fade into the blackness of the background, becoming unreachable and unobservable forever. The universe is an active process that is slowly moving its distant history forever out of our reach. Even if we could look past every galaxy, there is a final physical limit to what any telescope can see. In every direction, we eventually see the cosmic microwave background. This is a wall of glowing plasma left over from the very early universe. Back then, the cosmos was so hot and dense that it was opaque. Light could not travel through it. It was constantly scattered by charged particles. Because light cannot travel through this plasma, this wall marks the end of what we can directly see with telescopes. It is a physical shield that hides the state of the universe during its first few 100,000 years. The journey to the edge of the universe reveals that, while there are no walls in space, there are absolute limits to our perception. This is our information horizon. It is the point where the light of the early universe becomes a curtain, obscuring the conditions that existed at the very beginning of time. We continue to build more sensitive instruments, pushing against this horizon to capture every stray photon and gravitational wave the laws of physics will allow. Realizing that parts of the universe remain hidden ensures that the process of discovery is never finished. Every answer we find at the edge of the horizon only reveals how much more there is left to understand.